So in the last video, we basically performed enumeration on the target machine that we had just gained initial access to. So in this particular video, we're going to take it a step further and we're actually going to exploit the vulnerability that we found from Exploit DB. And again, I recommend that you check that video out. It basically gives you a basic understanding of enumeration and why it's important. So um, the specific vulnerability was a local privilege escalation vulnerability. And this was the code that this particular vulnerability provides. So this code basically would exploit that vulnerability. So me as an attacker, all I need to do now is just copy and paste this. So that's what I'm going to do. I'm going to copy and paste it. And I'm going to go to my machine. I'm just going to create a directory. Let's call it Exploit PE for privilege escalation. And create it. So this is the directory. And we'll just do ls minus. I like to just make sure it's there. And we see here exploit PE. So now we'll change into that directory. And basically what I'm going to do is I'm going to host this particular directory on a HTTP web server with Python. There's a Python app that allows me to host a HTTP server. And okay, it'll make more sense once we actually are doing it. So as I'm doing it, I'll explain it. So we're going to change directories into exploit P, and I'm going to do a nano, and I'll just name it 54321.c, because again, this is written in C, and the way the compiler works is it has to be, I don't know if it has to be this way, but once the code is compiled and we specify the name of the file with the code in it, the extension, if it's not .c, if it's like a .text, you'd have to. I basically had an issue where I was trying to compile the code, but because it was a .txt file, it didn't allow me to actually run the code on the target machine. So I've learned that you have to do .c as the file extension. So anyway, I'm back here. I'm going to click here and we see, and I'm going to make this screen bigger. And I'm just going to, if it lets me, so I'm going to have to go here to the clipboard, paste it in, and then here, and basically paste code that I got from ExploitDB. So here it is here. Should look familiar. This is the same code that we got from ExploitDB. I'm just going to scroll up to make sure we got everything. And again, this is written in C, and it is basically privilege escalation, local privilege escalation vulnerability. This code exploits that. So back on my machine as the attack machine, we can call it the attack machine. I'm going to go ahead and write out. And save that. We can do. So now we're back here. And now what I'm going to do is I'm actually going to add this to the web server. I'm going to host this actual directory. And now once I've hosted it, I can go back to the target machine and access this code and run it on that target machine. So I'm going to do Python 3 -m and http.server. And I'm going to specify the port as 8000. So now we see serving HTTP on 000 port 8000. So if we click this link, see if I can copy link address. Let's see if we can open the link. If not, I can just copy it. So we go to Firefox, which is trying to fire up now. Just to confirm, make sure that we can open. I probably should just copy and paste it because it's being slow. But anyway, we can come here and we'll actually see this is like a directory listing for this particular directory that I'm in, which is the I think it was the one I created. I think it was like exploit PE or privilege escalation. If I click here, boom, there's a code there. So now I know that it's actually being hosted. So there's one more thing that one more thing that I need to do. So I'm gonna get out of here and I'm gonna open up another terminal session and I'm gonna get the IP address. So I'm gonna do ifconfig and I'm just gonna note down this. See if I can find the IP address for this particular, for my particular machine is, let's see, 10.10.220.19. I have terrible memory. I suffer from CRS, so can't remember shit. Usually gets a few laughs. So I'm back on the target machine. I'm gonna change directories to the temp directory, and what I'm gonna do is I'm gonna do wget and then HTTP, and then that IP address that I've already forgotten it is 10.10.220.19. 10.10.220.19. And then the port was port 8000. So here we can see port 8000. So that's the port that we're going to be communicating with. We're using the communication with is port 8000, and then we're going to do a / again, and we'll specify the specific name of the file. So again, if I come back here, I named it 54321.c. So this is the target machine again, 54321.c. Make sure everything looks good. So we did a wget. Now press enter. So here we can see connecting to 10.10.220.19, 8000, port 8000. Okay, and we can see here 54321.c was saved. So sweet. So what does that mean? That basically means that this target machine now has downloaded this code that I created on my machine. I created, basically have a client server communication going on. So my attack machine was acting as a server, and the client was basically trying to act like a client and is trying to get, like, just like you go to a website and you go to like Amazon and you try to order something. You're the client, and Amazon is obviously going to be the server. It's going to be giving you the information. So I did the same thing here on the target machine. I was a client and I accessed the server and downloaded the HTTP. So you can see here connecting to 10.10.220.19, which is a server that I hosted that exploit on. And from here, we can see it was 100% connected, and we can see 54321.c, which was the name we named the exploit. So now what we're going to do we're going to actually need to compile it. So we're going to use GCC, which is a code compiler, exploit.c, we'll do -o, and we'll do pwned. These commands are like, just to give a brief understanding of GCC, basically like the code right now is we need to compile it. So GCC will basically compile it, and that will allow you to actually run the code. And so continuing on, we have GCC exploit dot C. Actually, that's not the name. It's 54321.c, 54321.c, and -o and pwned. So GCC, the name of the exploit file, which is here, 54321.c, -o pwned. We'll press enter, and nothing happens. So now we actually need to execute it. So we can execute it by using pwned, and we'll see that something happens. So we see that it's mounted and child threads are created, and we can see that it was actually created. So what we can do now is I'm going to type in ID, and boom, we see here root. We see here root, and that's a big deal because I'm not sure if I cleared the screen yet, but before we were just we just saw perfect. So when I did ID before I ran this exploit, we just had UID, GID, and groups. But after running it, we can actually see that, yeah, we're now part of the root users group. And what does that mean? We can do a lot more. We can actually do things that would infect the network. When you think of root access, that's like system administrator access. System administrator can do a lot more things. They can access domain controllers based on what type of access they have. And they can, when you can access domain controller, if we go to MITRE ATT&CK, this is a very useful website. It's for any cybersecurity professional. This is very important to know because it basically, this right here, it could look confusing, but this is basically the attacker's mindset whenever they're trying to perform an attack on a network. So you see reconnaissance, initial access, privilege escalation, a bunch of different things. But the most important thing to understand, in my opinion, would be impact, because impact shows what can happen if all these other things are successful. So what does that mean, what I just said? So we see account access removal, we see data destruction, we see data manipulation, defacement, resource hijacking, a bunch of things. These are all things that the attacker can do once he completes all of these tasks. This is like if you're thinking of the Cyber Kill Chain by Lockheed Martin, this would be basically action on objectives, or this is basically what the attacker exploited the machine, what he started with initial access. This is what his end goal was. Most of the time, the attacker is going to have an end goal in mind before he even attacks the system. So for this particular target machine, let's say I was actually an attacker and I wanted to encrypt the entire system. I wanted to encrypt the file system. I wouldn't be able to do that with regular user access, which is what I had before I ran it. So I wouldn't be able to do it because I just had basic access. But now that I have root access, I can actually look into the file systems, and as a root user, I'd have access to do some harm onto the file system. So if I do an ls-l, actually, first thing I want to do, I'm going to change directory. I'm going to go back because right now I'm in the temp directory. I went to the temp directory to run that code. So now I'm going to change directory back to home, and I'm going to do ls-l, and we see somebody named Matt. So we're going to change directory again. We'll do change directory, and we'll go to Matt, and we'll do ls minus l again, and we can see that there's desktop documents, example.desktop documents, and then we see something here, flag1.txt. Interesting. What could that be? Obviously, it's probably a CTF flag. So let's cat flag1.txt, and boom, there we go. We get a flag here. So we were successfully able to exploit this target machine. Obviously, this means that with the action on objectives was complete. We were able to exploit this particular vulnerability on this version of this particular kernel version. So in the first video, the first part of the video, we in the first video that I did in enumeration, we found that this was the kernel version, and then we found that this particular kernel version had this particular vulnerability, local privilege escalation. So we got the code from here, and we went to our actual attack box and created a HTTP server and hosted that code on that server, and went to the target machine. And on that target machine, we were able to actually download it onto this box, and gave us root access. So if we go to track me and we go to privilege escalation kernel exploits, we should be able to paste the flag to here. It's not the flag. I'll try it again. I may have to type it in manually. I hope not, but see if I can. See. And boom, there we go. So yeah, so now we were successfully able to do that. So like I was saying, with this MITRE attack, it's something important, especially if you want to do cybersecurity. This gives you a better understanding of thinking like the attacker, because it basically gives you from reconnaissance, where we're gathering information about our victim, to privilege escalation, which we did, initial access, which we originally had initial access, and then privilege escalation. And then obviously we want to do things like evade defense, because obviously if they see that we're compiling code, obviously organizations may have things in place to alert when certain things are occurring. So, but the most important thing to understand is, like, why would an attacker want to do privilege escalation is because it allows them to do more things. For one example would be ransomware, which is a very common attack that most organizations are hit with, is ransomware. And that's basically when an attacker is encrypting the file system and is telling the organization you have to pay money, and once you pay the money, we will give you your data back. So yeah, anyway, but that was basically this lab here. Very useful, and there's a lot of other ways to perform privilege escalation. This one we just based on the vulnerability of that particular machine. We did it this way, but there's plenty of other ways. And stick around. I'll definitely be posting more videos in the weeks to come on other techniques that attackers can use to escalate privileges and do more. And yeah, so thanks for watching. I hope it was helpful, and peace out and bye for now.